Hi students, good afternoon. Welcome to this video session. My name is Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall discuss your Module 1 homework assignment. This is your Module 1 homework assignment right here. These videos will be on my websites. It will be on two of my websites. So I'm gonna show you where it will be located. Let me speak like I'm from the south. I'm fixing to show you where it will be located, or I'm finna show you where it will be located, or I'ma show you. That is speaking like I'm from the south. So go to google.com and you type in Samuel Chukwuemeka. As you type it in, you see Chukwuemeka comes up, Samuel Chukwuemeka. And you just click on the first one here, samuelchukwuemeka.com. So when you click on this website, you click on my picture to enter the site. You click on mathematics. You click on statistics. And here you will see the module homework assignments and exam study guide. I have another one. If you go to google.com, okay, you go to google.com. And here this particular website is mobile friendly and tablet friendly. So you type in Samuel Chukwuemeka and then you type in AppSpot, AppSpot, and press enter key, and this website comes up, Chukwuemeka-Samuel, okay, .appspot.com. So this one is mobile friendly or tablet friendly. Okay, if you're viewing the videos on your tablet or on your mobile phone, you can use this website. And then you click on mathematics, and this is arithmetic shows up by default. You just click on statistics, okay, and statistics shows up by default, and then you look at the videos, notes, and resources. Okay, that is the two websites that I have. This one, samuelchukwuemeka.com. If you're viewing on your desktop or laptop, you can use this website right here. If you're viewing on your tablet or mobile phone, you can use this website right here, chukwuemeka-samuel.appspot.com. Okay, that is where the videos will be located. Okay, the statistics part here, and then the statistics part here under the videos section. We are gonna pull up our calculator. So just type in calculator. You see that I am using Windows computer. I'm Windows guy. So just click on this trusted Windows app, and usually it pulls up on standard. Okay, when you pull it up the first time, it shows you standard. Just click scientific. Okay, click on it and you do scientific. All right, for this module 1 homework, we are going to use technology to solve the problems. If you want to read the notes, then you click on the notes section to view the notes. Okay, you click on the notes section here, the notes tab for the notes. These are the but for this for primarily in this video, we shall use technology to do our work. We shall use the calculator here. We shall use the Statcrunch, Pearson Statcrunch as well to solve the problems. Okay, let's begin. Question 1, the following data represents the percent of owners of an electronic device that plan to purchase a replacement device within the next 12 months based on a survey of 1,100 adults in a certain country. Complete parts A through C. Okay, so that's the bar graph here, right here, the bar graph. Okay, so we need to click to view the bar graph, and then it says here what percent of game console owners plan to buy a replacement device within the next 12 months. So you look at the game console, and that is 10.4%. So you just click 10.4, type in 10.4. Yay! We got that. Then it says if there are 250 million individuals who own a cell phone, how many expect to replace their cell phone? How many expect to replace their phone within the next 12 months? Let's make this bigger. Okay. Within the next 12 months. I might need to restore this because I might need the calculator. So here they just asked about cell phone, and the cell phone is 14.8%. Okay, 14.8% expect to replace their phone within the next 12 months. So of course the sample here is 250 million individuals. So let's find the actual sample for the cell phones. Okay, this is the sample size, 250 million individuals who own a phone. How many expect to replace it within the next 12 months? So we just do we're gonna do 14.8% times 250. Okay, so just do 14.8% means divided by 100 equal to, then times 250 million. Okay, so this is 250 million, so not just 250. So 250 million, so you write 250, 1, 2, 3, 4, 5, 6 zeros, and that is 37 million. So we type in 37 million, 1, 2, 3, 4, 5, 6. Okay, 37 million individuals expect to replace it within the next 12 months. Okay, then it says here, if the results of the survey were claimed to indicate that 7.8% of adults in this country who own digital cameras plan to replace their camera in the next 12 months, would you say this statement is descriptive or inferential? And then why? So we talked about descriptive and inferential statistics here. If you look at this, introductory statistics, we talked about descriptive statistics and inferential statistics. So you can read it up in this note here, and there's a video for it as well. In this particular question, this, if we look at this bar graph, this is based on survey of 1,100 adults. Is a sample. Okay, this is based on sample. Now, if you now come and say that 7.8% of adults in this country, not 7.8% of 1,100 adults, you're now inferring on the entire adults in the country. Okay, so that is inferential statistics. You're no longer, you're getting from the sample, and you now infer on the population of adults in the country. So this statement is inferential because the survey reports on a sample of the country's population. It requires an inference to the population. Okay, so that is why you say it's inferential, and that is it. Question 2 you have this. A library took a survey to find the age distribution of 50 randomly selected new youth members. Okay, the results are shown below. So we're going to get the relative frequency, and of course the relative frequency is the individual frequency, the frequency of the individual class of that class divided by the total frequency. So let us get the total frequencies here. Let's get the total frequencies. So we have 3 plus 12 plus 16 plus 11 plus 8. And that gives us 50. So for this first one, the relative frequency for the first class will be 3 divided by 50. And that gives us 0.06. So we put 0.06. Okay. Next one, 12 divided by 50. 12 divided by 50 gives us 0.24. Next one, 16 divided by 50 gives us 0.32. Next one, 11 divided by 50 gives us 0.22. Next one, 8 divided by 50 gives us 0.16. Okay. And then check answer. There you go. Then it says here, what percentage of new youth members are in the 6 to 8 age group? Okay, what percentage are in that category or that class? 6 to 8 is 12, which is 0.24. Relative frequency can be expressed as a fraction or decimal or a percentage. So in this case, it is decimal, and that is 0.24. You just convert it to percent, okay, by multiplying by 100. So 0.24 times 100 gives you 24%. Okay. I just press the enter key. Then C, it says, what percentage of the new youth members are age 8 or younger? So age 8 or younger, you just add this class, the relative frequency of this class, and that of this class. Okay. So 0.24 plus 0.06 is 0.30. Okay. 0.30. Multiply that by 100, because that is age 8 or younger. So, and that is 30%. 30%. Okay. Do you understand it? All right. The next one, the data to the right represents the number of people from a certain county aged 5 to 64 who visited an optometrist over the course of last year. Create a relative frequency distribution. As usual, let us find the total frequencies. 1707 plus 3491 plus 6486 plus 6216. That gives us 17,900 patients. They asked us to round to 3 decimal places as needed. Okay, so as needed, 3 decimal places as needed means if our result is more than 3 decimal places, okay, if our result is more than 3 decimal places, then we have to round it to 3 decimal places. If our result is not up to 3 decimal places, then we can leave it like that. Okay, but we want consistency, so we do want to just make it up to 3 decimal places. If our result is 3 decimal places, that's fine. Okay, so if it is not up to, we can leave it like that, or we make it up to that. For consistency, we want to make it up to that by just adding zeros to make it up to that. If the result is 3 decimal places, perfect. Then if it is more than 3 decimal places, you now round it to 3 decimal places. That is what it means. So we do the first one. Let me store this in memory. So I'm gonna put m plus to just store it. Memory add to just memory first to store it in memory. Then I'm gonna do 1707 divided by, I record the memory, okay, equal to, and this gives me now 3 decimal places would be, let me move this right here. Let me move this closer. There you go. And then I move this right here. Okay. So here, 3 decimal places will be 0.095. Okay. The next one will be 3491 divided by, I record the memory, equal to, this one will be 0.195. Next one will be 6486 divided by recall memory, equal to, this will be 0.362. Like you see now, this is like paperless video. Honestly, I'm not writing any single thing. All the questions I'm gonna do here, I will not write anything. Like, I'm not writing anything on paper. It's all technology. Okay, but I have the notes for you and the videos of the relevant topics, so that you can first of all go through the notes and view the videos prior to doing this homework. Okay. The next one is 6216 divided by recall memory, and that is 0.347. 0.347. Enter. There you go. Okay. Then continue. It says create a frequency histogram. Okay. These are the frequencies here. Okay, these ones are the frequencies, the number of patients, and these are the relative frequencies. Okay, for frequency histogram, let's look at this. We look at this, that this is sort of in this 1707 3491. Then this is bigger than this. So there is an ascending order from between these two classes. Well, between the 3 classes there's an ascending order, and then there is just a descending order from the 3rd class to the 4th class. Okay, so if we look at this, we can look at what we can eliminate. Ascending, and then this. Okay, we eliminate B. Okay, we eliminate B because it's supposed to be ascending order. But B, the 1st class, is bigger than the 2nd class. So we eliminate B. We're going to look at A, C, and D. Okay. It might not be D because of the, because with D, you can compare 3491 and 6216. Okay. 6216 is bigger than 3491. So, but in D, this last one, 50 to 64 class range, you have 6216 as the frequency, and it looks smaller. Look at it. It looks smaller than 3491. It looks smaller than this. So D will not work. Okay, so we eliminate B and D. So let's look for A and C as the options we are going to look for. So we just magnify this, and we with the 35 to 49 class range is 6486. Okay, and then the 50 to 64 is 6216. The 5 to 19 is 1707, which is less than 2000. Okay, the the 20 to 34 is 3491, which is less than 4000. So D looks fine. 6486 for this one, and then 6216 for the last one. So D looks fine for A, not D. A looks fine for the moment, but before we check our answer, let's look at C. Remember, options B and D are eliminated. So let's check C. Okay, if we check C here, looks like this is less than 5000 because this is 1000, 2000, 3000, 4000, 5000. So you see, this class here, the two classes here is supposed to be more than 6000 in the frequency. But if you look at this frequency histogram, it is less than 5000. Okay, so C is out because this is 5000. So because of that, C is out and the answer becomes A. Okay, all right. The next one, it says press continue to see more. Continue. The next one is to create a relative frequency histogram. So the relative frequency histogram is this. The highest should be 1. Okay, if you sum the entire thing, it should give you 1. And actually, that is the way you check for relative frequency histogram. If you add up all the relative frequencies, it should give you 1 or 100%. Okay, the sum of all the relative frequencies should give you 1. So you could do that here, and also the previous question. You could do that. If you add it up, it should give you 1 or approximately 1. This one we did some approximations, but if you do that, it should give you 1. Should give you 1 if you add the whole thing. That is the way you check for it. Okay, so let's choose this. The relative frequency histogram would be, we have something like an ascending order for the first 3 classes, and then there's a descending order from the 3rd class to the 4th class. So A is out of the way. It could be B, it could be C, and then D is out. A and D are out. Okay, now let's look at B and C. Here we have 0.362 and then we have 0.347. So let's magnify option B. Option B shows that the relative frequency of the 3rd and 4th class are less than 0.3. You see that? But it should not be. Okay, so option B is out. Let's look at C. Magnify this. So we are now left with only C. Okay, so C should be the answer. So that is the way you check it. Okay, then it says what percentage of patients were between 35 and 49. So we look at the relative frequency between 35 and 49 is 0.362, and it says round to the nearest tenth as needed. So this is 3 decimal places, so we are still good. Okay, so we just do 0.362 times 100, and that gives us 36.2. Now I would really advise you, okay, if you want, you can just do this again. 6486 divided by, recall memory, okay, times 100 times 100, and then round to the nearest tenth, so 36.2. Okay, come here, you put 36.2, the same thing. All right, the next one, what percentage of patients were 34 or younger? So here, let's just get it from here. 3 491, 34 or younger, plus 1707 equal to, and then divide by the sum. I'm recalling the memory here, equal to this, then times 100. And that gives us 29.039, and then nearest tenth will just be 29.0. Okay, 29.0. Okay, that's it. Question 4, the accompanying data represent the percentage of recent high school graduates graduated within 12 months before the given year end who enrolled in college in the fall. Construct a time series plot and comment on any trends. So I'm going to come here, click the icon to view the data table. I click this icon, and I'm going to just come here, and I will open this. I click on this icon here, and I open in Statcrunch. I open this in Statcrunch. So this is a time series data. Let me bring the Statcrunch close here. See everything. Okay. I need to see this. Okay, just let's look at this. This is the data right here. I opened it in Statcrunch. I know I'm not seeing one of these options, but that's fine. We shall look at it. You just come here. You can space this out so you see this percent enrolled. And they want us to construct a time series data on this. I want to actually pull this so we could see that. Let me minimize this. So ABC here, and I see this. All right, so we just go to graph. Here we don't see anything in time series. That's fine. We can just do a scatter plot. That's fine. We can do a scatter plot. And here the X variable, as you can see here, the X variable is the year, and the Y variable is the percent enrolled. So X variable get the year, Y variable get the percent enrolled. I mean, if you want to look, you can do this by inspection. Okay, you compare it, but like I want to save time. Okay, otherwise you can do by inspection. You compare it with the. This is what I mean. Let me cancel this so I show you what I mean. You can do this by inspection. You magnify this, and then you compare it, just like we just did in the previous question for the frequency histogram and the relative frequency histogram. You can do that. But I want to save time, okay? So what I'm going to do now is I'm going to do a scatter plot, and then I just do it very fast. So I just go to graph. I'm going to do a scatter plot. My X variable, as you can see, is the year. I select the year. Y variable is the percent enrolled. Okay, and I just click compute. So now what I want to do now is to, let me minimize this. I just need this and this. So I want to now compare. I want to compare this. I want to compare this and this. So which graph looks like this? If you start joining this, you see which one looks like that. We know that it's not C. It's not going to be C. You see, it looks like A, as you can see on the scatter plot. You see, it looks like A. So A is just the answer right away. Okay. And then it says, comment on any trends. Choose the correct comment below. So the percentage of high school graduates who enrolled in college has generally decreased, though there have been some up years. There are not any trends. That's not true. And A is not true, because as you can see, the percentage was low right here, and it's by 2005 is up here. Okay, so the percentage of high school graduates who enrolled in college has generally increased. Yes, though there have been some down years. Yeah, as you can see, there have been some down years right here. Down years. Okay, but generally it has increased. So the answer is C. Yowa. All right. Question 5. For a large sporting event, the broadcasters sold 58 ad slots for a total revenue of 161 million. What was the mean price per ad slot? This question came out. I did this question in finite math. So let's get back on my website here on the notes. On the notes section. So I did this question on like Module 3 homework study guide, but that was for 130 applied finite mathematics. Okay, so you can look at, just finding the mean. That was this question right here. Okay, this is just the question right here. See that? But I put it under statistics notes. Okay, but it's actually finite math question. I put it under statistics notes. Module 3 homework study guide. Okay, so if we do this question, let me go ahead and close this. Okay, let me go ahead and close this Statcrunch. So you just, divide this by this. Okay, you have 161 million. Now the answer is gonna be in million, so you don't need to type the whole thing, the 6 zeros. Just do 161 divided by 58. Okay, and they want it in a 1 decimal place, so 2.8. Let me, because I want to be saying this. So that is 2.8. 2.8. There you go. Question 6, there's an instructor tip. You can look at those, okay? But that's fine. The following data represent the monthly cell phone bill for a person's phone for 6 randomly selected months. So calculate the mean, median, and mode phone bill. And I did this question still on a Module 3 homework study guide. Excuse me. Something like that. I did it here. And I did the videos of these as well. Okay, I did the videos of these as well. So the mean, median, and mode is somewhere here, which you can find. I think it was probably the first slide. Okay, there you go. Yeah, this is an example of that. Okay, but this is how you can do this to save time. I'm gonna open this. I'm gonna click right here. Okay, open in Statcrunch. And I will just come here and I can say just phone bill. Please, no space in the variables. Okay, no space. Then I'm gonna go to stats, summary stats, and this is in column. This is in column. Okay, this is in column. So summary stats, I select columns, and then I click phone bill. Click phone bill, and then I need the mean. Okay, watch me now. Okay, I just clicked one time. I got the mean. Press your control key. Press the control key on your keyboard. If you're using Mac, I think maybe you press the command, I'm not sure. But you press the control key on your keyboard, and then you scroll down, press the median. Okay, if you make multiple selections, you have to press the control key after the first selection, and then you click on mode. Okay, and you click compute. So the mean, round to the nearest cent. So the mean is 41.41. Okay, the median is 40.76. Okay, and then no mode. There is no mode. Okay, all right. The next question, let me close this Statcrunch. A random sample of 15 college students were asked, how many hours per week typically do you work outside the home? Their responses are shown on the right. Determine the shape of the distribution of hours worked by drawing a frequency histogram and computing the mean and median. Which measure of central tendency better describes hours worked? So let us do a frequency histogram of this. So I'm going to come here. And if you want to check this, you can. But I'm going to do this now with Statcrunch. Okay, I'm going to draw the frequency histogram of this on Statcrunch. Then I'll compare it. So I'll open it. But if you want to compare manually, manual inspection, that's fine. So I just open this here, open in Statcrunch. And this is hours per week. Do they work? So work hours. Please, no space. Otherwise, just leave it as variable 1. Okay? Do you see there's no space between work and hours? Okay, and this is camel casing. Please avoid putting spaces in your variable names. Okay? Otherwise, just leave it like that. So I have to draw a frequency histogram for this. So I'm gonna go to graph. Let me restore this. I go to graph. I go to histogram. I select work hours. That is what I need. And the type will be frequency histogram. Okay, frequency histogram. And I just click compute. So I want you to compare which one is which. Okay. You see, A is not that. No. B looks like that. C is not that at all. So if you compare this, so the answer is B. Okay, it's skewed. Now, some of you might ask me, okay, why didn't you use Statcrunch to do the frequency histogram for the group data that we just did? Okay, so in the previous question, you know, we had to do it manually. We had to do by inspection to see which ones were the correct ones. Okay, so the other one was a group data. It was grouped in classes, in categories. It was grouped in classes. This one is just the raw data. It's not a grouped, it's an ungrouped data. With an ungrouped data, Statcrunch does it well. With a group data, Statcrunch messes up. Okay, so Statcrunch will mess up with a group data, but on group data, it does it well. Okay, so that's fine. You can even do this one also by inspection, but I want to save time. Okay. This histogram is skewed. As you can look at this points to the left. It's skewed to the left. It's skewed left. So I did example of this here. So this is normal. Okay, this symmetrical is normally distributed. Here is skewed left. Here is skewed right. Okay, you can look at it here. Symmetric here. Here is skewed right. Here is skewed left. So back to this question. In this case, you see here it points here it points towards the left, so this is skewed left. The tip points towards the left, it's skewed left. And they asked us to find the mean. So let's find the mean and median. Okay, so I'm gonna get back to this. I'll just close this. I'll go to start, summary stats, columns, get the work hours, get the mean, press your control key and scroll down, press the median, compute. Okay, so the mean, round to 3 decimal places. For the mean, round to 3 decimal places. The mean is 18.2. 3 decimal places as needed. Okay, so as needed, which tells you that if it is not up to 3 decimal places, leave it like that. Okay, that is what it means. But if it is more than, if it is 3 decimal places, that is good. You write it like that, you leave it like that. But if it is more than 3 decimal places, then you have to round to 3 decimal places. So this is just 18.2. Okay, and then the median is 20. Okay, you just type 20. That's it. Then, which measure of central tendency better describes hours worked? So when you have a skewed data, if you have skewed right or skewed left, the median is the best measure of central tendency for that data, to describe the data. If you have a symmetrical normal distribution, if the data is normally distributed, which means there's no skewness, no skewed right or skewed left, okay, if it's symmetrical, that means you use the mean. The mean is the best. So here, the answer is median. All right. Next question, compute the range and sample standard deviation. Let me close this Statcrunch here because I'm gonna open up another one. Compute the range and sample standard deviation for the strength of concrete. Okay, so open in Statcrunch, and here I'm just gonna type in strength because it's strength of concrete. Strength, that's it. I go to stats, summary stats, columns, select strength, and they want us to find the range. So look for the range, click on it, hold your control key, press down your control key. So here you have, this is some, you have standard deviation, std.dev dot, and I don't mean std as in help. Okay, standard deviation. Okay, and you have the unadjusted one, unadjusted standard deviation. This is the population. So, but this is the sample here. So you select this standard deviation. This is the sample. Compute. Okay, so our range is 1200. I need this here. Our range is 1200 psi. Okay, and then our standard deviation is they say round to 1 decimal place as needed, and this is more than 1 decimal place. This is 5 decimal places for the standard deviation, 486.59164. So we now have to make it to 1 decimal place, which will give us 486.6. Okay. The next one, compute the range and sample standard deviation of flight time. Okay, this is for flight time. So let me go ahead and close this. And let me open this up in Statcrunch. You can also do this in Excel. Okay, let me say this. You can do this in Excel. You can do it in Google Spreadsheets. If you need help doing it in Microsoft Excel or Google Spreadsheets, just send me an email. Okay, please do not contact me from my website if you are my student. If you're my student, please do not contact me through my website. Just send me an email using the school email. Use your own school email and send it to my school email. Please do not contact me from my website. Okay, if you need videos on using Excel, Microsoft Excel, or Google Spreadsheets, or if you need me to walk you through it use over the phone, I can also do that. Just send me an email, okay? The variable here is flight time, so I'm just gonna name this variable flight time. If you know you will mess up in naming variable, please don't name it at all. Use it as variable 1, var1, var2, okay? But I like naming mine to correspond to the question. As you name the variable, it is recommended, highly recommended, you don't put spaces, okay? They want us to find the range and sample standard deviation. Click on Start, Summary Stats column, select this, and I scroll down to get the range. I see the range, I click on it. Then you press the Control key and you look for standard deviation. Okay, you click Compute. So the range is 30 and the standard deviation to 1 decimal place will be 10.3. all right, there you go. Okay, question 10, you have an instructor tip. Please, you can look at it later on. I'm just gonna do it, okay? Here, the following data for a random sample of banks in 2 cities represent the ATM fees for using another bank's ATM. Compute the range and sample standard deviation for ATM fees for each city. Which city has the most dispersion based on range? Which city has more dispersion based on the standard deviation? So these are measures of spread, or measures of variation, or measures of dispersion. Okay, I have the videos on my website as well. So I'm just gonna, let me close this right here, and this is ATM fees. So I'll open this, open in Statcrunch. Okay, I have the ATM fees city A, city B, range for city A. So I'm just gonna kill 2 birds with 1 stone. Will I use the word kill? I'm sorry, I wouldn't use the word kill. Okay, I'm just gonna do 2 things at the same time. So start, summary stats, columns. I will select city A, use the Control key. Anytime you make more than 1 selection, press the Control key and click on that. Okay, city A, city B, and I need the range and standard deviation. So I come over here, I click on range, then I press down the Control key on my keyboard, and I move up, I press the standard deviation, and I click Compute. All right, let's go and answer this now. So for city A, range is 2.5. okay. For city B, range is 0.5. Standard deviation for city A, round to the nearest cent as needed. So this will be 95 cents, 0.95. And then standard deviation for city B is 25 cents, 0.25. Okay. All right, continue. Which city has the most dispersion based on range? So based on range, we say city A because it has a higher range. Okay, so the answer is B. Press continue. Which city has the most dispersion based on standard deviation? Based on standard deviation, we also see that city A has the most, has the higher standard deviation. So city A, because it has a higher standard deviation. Okay, that's it. Question 11. Determine whether the random variable is discrete or continuous. In each case, state the possible values of the random variable. Let me close this Statcrunch. This question is, if you go here, under the notes, this is under probability distribution, okay, on my website. Probability distribution, you can read it. Discrete means you can count it. Continuous means you can measure it, okay. Discrete, if you can count it, is discrete. Number of. If you can measure it, it is continuous, okay. Amount of this. So back to this question. The number of points scored during a basketball game, okay. Of course, this is discrete, and the possible values are x equal to 0 because no point, 1 point, 2 points. So it's discrete, and the possible values are no point, which means x equal to 0, 1 point, x equal to 1, 2 points, x equal to 2, and so on and so forth. Okay. Then the weight. Can you count weight or do you measure weight? Okay. If you can count it, it is discrete. If you can measure it, it is continuous. So weight, you can only measure it. So it's gonna be continuous. I know we talked about probability distribution. This is also here for finite math, applied finite math. I did something like this in the Module 1 homework study guide. Okay. Something like this. Number of letters of alphabet of Igbo language. I'm an Igbo, by the way. Okay. Igbo language. I'm an Igbo, by the way. So something like this. I also did it here. Discrete and continuous. You can also look at it. This is the first note you should look at. Probability distribution. So the weight is continuous, and the possible values you can have, because it's continuous, so there are several weights in between. You can't have it as 1, 2, 3. No. So we just say weights are greater than 0. Okay, continuous. And that's it. Question 12. Determine the required value of the missing probability to make the distribution a discrete probability distribution. With a discrete probability distribution, the total probability of the events, the sum of the probabilities, must be equal to 1. Okay, the sum of the probabilities will have to be equal to 1 with a discrete probability distribution. When you add the entire sum of all the probabilities, it should give you 1. Okay, you can read it up here. You can also read it up here under probability, under these notes on probability. Okay, so back to that question. We'll add all this and then we subtract from 1. So I'm gonna do. I know I had a recall memory. I'm gonna just clear the memory. Okay, and once you clear it, it's no longer highlighted. That means there's nothing stored in there. So I'm gonna add this up. 0.16 plus 0.42 plus 0.24 equal to this. I will store this. I want to store this. Store it in memory. Once you store it, you see this is highlighted. Now I will now do 1 minus recall memory. Recall the memory. And that gives me 0.18. Okay? So 0.18. There you go. There is an instructor tip for question 13. You can look at those. Okay. Here, the probability histogram to the right. represents the number of live births by a mother 45 to 50 years old who had a live birth in 2012. A. What is the probability? Please, I would like you to look at the notes and videos on probability, okay? And also probability distribution. Very important. These two notes, very important. And the videos are on the videos here. The videos are here, okay? Probability and probability distributions. So it says, what is the probability that a randomly selected 45 to 50-year-old mother who had a live birth in 2012 has had her fourth live birth? Fourth live birth is 0.113, as you can see from this frequency histogram. Okay, as you can see from this histogram, or let me say probability histogram. Actually, it should be probability histogram, okay, not frequency histogram. Okay, so this will be 0.113, okay? There you go. Then it says, what is the probability that a randomly selected 45 to 50-year-old mother who had a live birth in 2012 has had her fourth or fifth live birth? Fourth or fifth, so we add both of them. 0.113 plus 0.104 equal to 0.217. Okay. Okay. C. What is the probability that a randomly selected 45 to 50-year-old mother who had a live birth in 2012 has had a sixth or more live birth? So we're going to count from the sixth, okay, down. I mean sixth up. So we have 0.031 for the sixth plus 0.035 plus 0.054. And that gives us 0.12. Okay? 0.12. Okay? Then D, it says, if a 45 to 50-year-old mother who had a live birth in 2012 is randomly selected, how many live births would you expect the mother to have had? This is expected value. Okay, an expected value is the mean of the probability distribution. If you look at these notes, I explained it there. Probability distribution. So this is the formula we are gonna use. This is the formula you're gonna use here. Excuse me. The mean. So this is the expected value. Okay. I also mentioned it somewhere here. Expected value is the mean of the random variable. Okay, this is the formula you're gonna use. Okay, so you can look at it there. I'm gonna use Statcrunch to solve this. Okay, like I said, I wanna use technology for this video. So I will just open Statcrunch. Okay, open Statcrunch, and I'm gonna put this in a probability distribution. This is number of live births and then probability. So what I will do here is, watch me do it. I'm gonna come here. I'll put X. Okay, the X is the number of live births. Okay, my X is number of live births, and here will be probability of X. Probability of X. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, because they told us to find the expected value, and that is the mean of the random variable. You can use that formula and see the example the way I did it, but I want to do it with Statcrunch to save time. Okay, so I have this, And then for probability for one live bet is 0.239. The next one is 0.260, 0.164. Next one 0.113, then 0.104, 0.031, 0.035, and 0.054. All right. So look at what I'm gonna do. I'm gonna find the mean of this probability distribution. So I go to Start, I go to Calculators, I go to Custom Calculator, Custom, and my values of the variable is X. Okay, and the weights are the probability is P of X, and then I click Compute. All right, let me get this back. And this is what I have here, that the mean is 3.086. Mean is 3.086. So round to one decimal place will be 3.1. So I come here, I write 3.1. Okay, that's it. Last but not the least, suppose a life insurance company sells a $150,000 1-year term life insurance policy to a 21-year-old female for $210. The probability that the female survives that year is 0.999549. Compute and interpret the expected value of this policy to the insurance company. Okay, so we're going to form a this is also a probability distribution. I'm gonna just close this and open up a new Statcrunch. So let me just call this my X, and then this is the P of X. Okay, probability of the random variable. If the girl okay, so here, if the girl survives, she will just pay $210. Okay, if she survives. Okay, and so if she will just pay $210, so here I'll put 210, and then the probability that she survives is 0.999549. Okay, if the girl does not survive, then the insurance company will pay. That will now be, we're gonna do one. Let me clear this memory here. So we're gonna do first 150,000 minus $210. So this is the amount the insurance company will pay if she doesn't survive. Okay, we hope she does anyway. So this will be negative 149,790. That would be a loss to the insurance company. Okay, here this will be a gain. That's why it's plus 210. That's what the girl, the female, pays to the insurance company if she survives. And this is the probability that she survives that year. If she doesn't survive, which we don't hope that she does, which we hope that she does survive. We pray she lives and praise God. Then the insurance company will have to pay this. Okay, so you have to put a negative sign here, and then the probability of that will be 1 minus 0.999549, and that gives us 0.000451. Okay, this is what we need here, and then we go to, I'm gonna minimize this. We go to Start, Calculators, Custom. Select these values in X here. Weights is P of X, and click Compute. So here the mean is the expected value, and this will be 142.35. Okay, $142.35. Okay, there you go. Which of the following interpretation of the expected value is correct? So, this is one of the applications of this for the insurance company. This means that the insurance company expects to make an average profit of $142.35 on every 21-year-old girl. Okay, every 21-year-old female it insures for a year. That is the profit it makes. Now, if this value gave us a negative number, then that would be a loss. Okay, but it gave us a positive number. So this is an average profit it expects to make on every 21-year-old female it insures for 1 year. So that's a check answer. All right. At this, we have finished the whole thing. If you have any questions, please feel free to ask. Thank you so much for listening to this video. And you have a great day.